Hey guys, welcome back. So today, working on this 3200 watt ETQ generator. This one was dropped off by Jason. He's a local guy who buys and sells equipment, and he usually sends me his generators that don't run. That said, he didn't actually try starting this one. I think he just assumes it doesn't run because he found it in the trash. So someone threw it away. Chances are there is an issue. And I did take a peek in the tank. You know, it is empty, but I do see we have some rust issues. And I also noticed that the fuel line is disconnected. So I'm sure at a minimum we do have some fuel system issues. You know, that said, the rest of the machine looks to be pretty complete. You know, nothing's broken or missing. And we even have the red shipping brackets still installed. They're supposed to be removed before first use. So potentially, this has never been used? Kind of doubt it. So let me get you set up a little bit better. I think we'll start just by checking the basics, give it a little bit of starting fluid, and see if this thing comes to life. I want to hear what the engine sounds like and see if the generator is any good. All right, let's see what we have for oil here. Yeah, plenty of oil, and it's nice and clean. So, yeah, I would say this actually has not seen much use, or potentially someone changed the oil right after they last used it. Whatever it is a good sign. So before moving on here, let's just get these red brackets off. There's one on each side, and they're only there for shipping. You don't want to leave them on here because that defeats the purpose of the insulator. The engine and the generator are floating on these rubber mounts to keep the vibration down. So we'll get those off, and then I think we'll try to start it. Get that tag out of the way. Kind of a pain to get those off. Let me get an extension, that might help. Yeah, it looks like the vent for the fuel tank is broken off the airbox, so that is not good. That means we need a new airbox if we want it to function the way it was designed. I mean, quite honestly, you know, it would also be fine just to leave it. You know, this is just a vent for the tank, and it's more an evap thing. You know, if the engine's running, you recirculate the fuel vapor, but most of the time, generators aren't running, so I'm not really sure there's huge benefit there. Anyway, let's get the drain bolt out, just see if there's anything in there, and we can look at the condition of the bolt. If it's rusty or varnished, then we know the rest of the carb's going to look the same. All right, and there was some fuel in there. That is the fuel that just came out of the carburetor, or at least it's supposed to be fuel. You know, in this case, I think it is all water. So, yeah, not a good sign. The bolt for the drain actually looks pretty good. I don't see any varnish, no rust. So this carb, I would say, has a chance. So I'm just going to put this back, and I am going to feed the carb some fuel. We'll see if it accepts fuel. I'm just going to pull this airbox off. You know, I'm sure the carb's going to have to come off. And with the airbox installed, it's a little bit more difficult to get a fuel line on there. I want to put on a clear fuel line so that way I can see a little better if the carb is taking any fuel. So we'll get those bolts off. There's also one in the back. And the rest of this airbox should come right off. I can see too, looking at this fuel valve on the tank, a bunch of corrosion inside, so it might potentially be blocked. A lot of times you can save the gasket by tapping on it to free it up. If you just rip it off, you're going to rip the gasket almost every time. You know, in this case, I might rip it anyway because it wasn't letting go, but it looks like we're okay. And these clamps, they're really, really rusty, so we will not be reusing those. That one's really stuck on there. So might need to cut it off. Oh, there we go. So we'll add that back. We'll just torque this back down, add a clear fuel line, and see what this carb can do. Make sure the throttle's not stuck, especially with old fuel. The resting position is full open throttle, and if that throttle plate rests in place and the carb is still able to run the engine, then you're going to run it at full open throttle and most likely cause damage if you don't shut it down in time. Right now the carb is completely empty, so if we add some fuel to this line, should go into the carburetor. And it didn't. The fuel line immediately filled up, so we have most likely a stuck needle, or maybe this fuel inlet's clogged. So yeah, this carb, it is not going to run the engine. Got a name brand NGK BPR6ES and looks to be in pretty good shape. So I'm going to put just a bit of fuel in the cylinder. This is two-stroke mix, so there's a little bit of oil in there, which is always a good idea, especially on something like this where it hasn't run in a while. You want to have some oil in the top end to help it out. So what do you think? Is the engine going to run? Is it going to sound good? And most importantly, is it going to make power? Based on what I see with the fuel system, I would say most likely. Let's give it a try. Let's try it with the choke off. Nice. I'll take it. The engine sounds good, and we're making power. So there is nothing serious wrong with this machine. You know, we have a carburetor that is clogged up and a fuel tank with rust in it. So I say we get the tank off. I'm going to set it aside for now. And let's get the carburetor off as well. We'll get it up on the bench, open it up, see if it can be saved. All right, let's see how bad this one looks. Yeah, a bit of rust and varnish on there. Bowl came right off, and wow. Yeah, that is pretty bad. This pin is stuck. Needle, surprisingly, is not stuck. So, yeah, should this one be cleaned? Yeah, probably not. You know, these carbs are dirt cheap on Amazon. They're probably like $15. And this could be made to run again. Maybe. So, yeah, I'm going to stop right here. I actually have 3 other carburetors just like this. They're in a bin. They're most likely there for a reason, but I think they're in better shape than this. So let me get them out. We'll take a peek inside, pick the best one, and give that a go. All right, I actually only found 2 alternatives. So let's see what this one looks like. And I can tell from the bolt there was rust in here. Not terrible. So this one looks to be complete. Not too bad. And let's see what's in this one. Bowl nut looks very clean. And the carburetor looks essentially new. We've got a needle and a pilot jet. So I think this one's our winner. I am going to try to get this main jet out. I want to measure the size. I mean, usually they are the same, but I just want to make sure, you know, potentially we need to swap some jets. So let's see if by any chance the main jet will come out of this one. Yep. And there it is. So 71 fits. I'm actually missing 70, which is the next size up. Let's try a 69. 69 fits. 68 does not. So we'll set that aside. We'll get this jet out. $69 fits. And so does a 68. And a 67. So this jet's actually larger. So 67 is where it stops. Let's just try this jet again. You know, potentially it is just gummed up pretty bad. And it might be a little larger than I think. Yeah, the original is definitely a smaller jet size, so yeah, we might have to downsize. I guess we can double check this other one just to see what we have. I mean, I could always clean up that jet as well. And let's check this one. The 69 drill bit size fits. The 68 does not. So this jet matches the original. So we're going to use that one in this carburetor. And I was just looking down here, looking at the emulsion tube, and there is none. So that's why this one's in a bin. I remember this carb now. It actually came off a Predator that was running very poorly. And that's because it was missing the emulsion tube. So the last guy must have taken it apart to clean it and just never put that part back. So we can steal the tube from this carb, if it'll come out. Yeah, let me get an Allen wrench. I can kind of poke that tube out of there. All right, so that will go right in there with this jet. And this one we can kind of just keep in the back of our mind. If this carb ends up running too lean, we can swap that other jet in. Yeah, that didn't feel right. And that emulsion tube did not go all the way in, so potentially it's not compatible. Yeah, for some reason that emulsion tube is not dropping all the way in, so it's not compatible. And I noticed another issue here too with the choke. It's supposed to have like a detent where it snaps in place. And yeah, that part is broken. So this carb I would say is out. So that only leaves us with this one. Which doesn't look that bad really. So let's put this back in this carburetor. Emulsion tubes all the way in. Detent works, and I think this was the jet we said we were going to use. Yep. We're missing a spring on this needle and float assembly, so let's just set this one aside. We'll see if this one has it, which I think it does. Yeah, you can see the spring right there. So we'll put this one on. Use the original pin. That seems better. Put the gasket on, which looks like it's a little bit small. Let's try to steal this one. That looks good. And the original bowl, it's not too bad. There is some rust in it. So we're going to swap the bowl to one that's nice and clean. And we'll use the gasket and the bowl nut that goes with it. That should do it. That's not good. Throttle stuck. Not sure why, but there does seem to be a ton of slop right there, and it's causing that governor rod to bind. So unfortunately, this carb's out. So for whatever reason, this isn't in very good condition. It's not connecting to the governor rod very well, so I'm going to try to just uninstall this shaft. We'll put the one in from the carb that was originally on this machine, and if we're really lucky, it'll fit. Yeah, they look a little different, so I'm not so sure this is going to work. I think that's going to work. Yeah, I think that's going to work. We'll just put the anti-surge spring on here. This takes out the slop between the governor arm and the governor rod. I think that's going to work. All right, let's give this Frankenstein carb a try. So it should run the engine. I guess the question is how well. You know, I have two-stroke fuel in there. There's no air box, so it might run lean, but it should run, and hopefully without surging. So I guess we'll find out in a minute. Also this time, the engine should run quite a bit longer. So we'll double check the outputs and see where we're at. Ignition on, choke on. Now the choke's off. All right, not great, but not terrible either. You know, the engine started fairly easily, but the carburetor was not running it well. It was surging pretty bad, so I did have to apply the choke partially to get things to smooth out. Once the engine was running better, I double-checked the outputs, and things looked pretty good. We're at 121.5 volts. the frequency was at 63.3 hertz, which is a bit faster than I'd like, but that is what I usually see on this size engine. They tend to over-rev them a bit in order to get the rated output, so I'm not too worried about that. Anyway, I went to shut it down, and the switch did not shut the engine down. So we do have issues there. We need to take a look at that. The way I ended up shutting the engine down was by choking the engine fully and just flooding it out. Anyway, as far as the carb goes, most likely I'm going to have to buy a new one, but it is acting like a clogged pilot circuit. And on this size engine, they tend to run very lean, even when brand new. I've had to drill these pilot jets out on new carburetors, so I might drill this one out. So let's pop it out. Let's just double check it, see if it's clogged. It might be as simple as that. If it's not clogged, we'll drill it a few sizes up and try it again. That's the idle set screw that just landed on the floor. This generator is not idle, so you don't really need it other than to help hold down the pilot jet. And that's came out pretty easily, so I'm wondering if that was the issue. If that wasn't seated well, we'd have a vacuum leak. And it's hard to see. There is actually a black O-ring on there. It seems like it's not missing. Just double checking how easily this comes out. Yeah, it's pretty loose in there. So maybe we just need to swap this jet out entirely. Yeah, jet's not clogged. And the only drill bit that fits in there is the 79, which does seem pretty small. Let's double check the pilot jet on the carburetor that came on here. That one was pretty loose too. $79 fits. And the next size up does not. So they do appear to be the same size. So I think we do need to drill the jet out. I'm going to start with the 78 and most likely go to a 77 or a 76 in the end. Going one size on these usually is not enough. But if you're going to drill a jet out like this, make sure you have an extra. Because these drill bits, they do break in the jet. And they are hard to get out when that happens, so just be careful. All right, we are through. So let's go up one more size. So this is the number 77 drill bit, which, despite the smaller number, is actually the larger size. And it actually has the measurement here in inches. So the 78, if I can read it, looks like it's 15 thousandths. The 77 might be 18 thousandths. And I think I remember the generator this carburetor came off of. It came off of the generator because it was surging so badly. So it's probably not a pilot jet issue. I mean, potentially it is undersized. I would say more likely, though, some of the internal passages in that carburetor might just be clogged up. And I know I ran it through the ultrasonic quite a few times, so I could do that again, but I'm more inclined to think we're dealing with a jetting issue since I don't think I drilled this out originally. Actually, I definitely drill it originally. So the 77 is now through. So let's try this one out. And as far as the switch goes, I'm just going to use the multimeter. Right now I have it set in continuity mode. So when these two leads touch, we get a beep. This is the switch in question. Right now it is turned off. You can see one of the wires connects over to body ground, and the other one goes down here and looks like it connects into that harness. And I may not even need the multimeter. That right there kind of looks suspicious. Like it's not plugged in all the way, but it is plugged in. Well, not anymore. So let's test from the ground right here to the other end of the wire. So the switch is off. We should get a beep. And we do. Let's double check this is making a good ground connection from that screw to the generator. So no issues from ground over to the switch. And it is turned off. Let's turn it on. We'll do the same test. We should get no connection. And we don't. So the switch is actually fine. We're getting a good ground signal. So the issue must be down here. Let me get this bundle of wires out so we can get a better look. Yeah, there's really not much to it. This black wire right here runs over to the coil. That's what should be grounding the engine out. The wire appears connected, and it goes to the harness where we just unplugged the switch wire. So we know it's good up until here. So either we have an issue with this harness, this connection here, or maybe the wire going over to the coil. Oh, I think that's the problem right there. Do you see that? It's not actually plugged in. I mean, it's kind of touching, but not plugged in. So let's push that in. Now we have a good connection. And we can actually double check that the wire is continuous over to the coil without, removing the blower housing and actually taking that coil off. So let's just do that real quick. Make sure we have a connection over to that ignition coil. So from this wire, which should be connected to the kill tab on the ignition coil, to ground, we should measure the resistance of the primary on the coil, which I don't have the exact reading on, but I would expect, somewhere in the 100 ohm range. So we'll just flip the meter over to measure ohms, and I know you can't see it, so I'm going to have to tell you what it says. It actually says 1 ohm. So, yeah, that seems a little low. But it's not open circuit either. So I actually don't know what the reading should be on the primary on this 212cc Honda clone. So I thought I would do a reality check here. I do have an ignition coil. This is actually from a 420cc clone, so not exactly apples to apples, but it should give us kind of a ballpark reading that we can use and apply to that other engine. So I'm going to put one probe here on this wire. This runs over to the kill tab and the other lead on the body of the coil. Now, on the machine, we weren't doing that. We were actually testing body ground. But the thought process behind it is that this metal on the coil, it's mounted to the engine. It's making direct contact. So as long as you have a good connection between the ignition coil and the actual body of the crankcase, then you can kind of get away with that cheat. You know, in this case, we're going direct. So from the kill wire to the body of the coil, and we get a reading of 1.5 ohms. And that's pretty similar to what I just saw on this other clone. So, you know, I think we're fine. The issue was the wire just wasn't plugged in. So we'll just plug it in and put this one back where it was. That should solve the problem. All right, let's try this again. The carb is refueled, and I've got you set up with a good view so you can kind of see what's going on with the governor and the choke. So let's turn the ignition on, turn the choke on partially, and let's give this a go. There's really no difference on the way this carb is running after drilling it out. So I'm going to have to say here that most likely we have an internal blockage in the carburetor, and we're kind of out of options here. We do, I think, need a new carburetor. On the bright side, the switch shut the engine down, so we are making progress. So I'm going to place an order. We'll get a brand new carburetor, and while waiting for that, we'll get that tank cleaned up. Change of plan. It's the next day, and I ordered a carburetor from Amazon this morning, and it showed up less than 12 hours later. Anyway, this is a kit. It includes a spark plug, a fuel valve, and a few other things, which we don't need for this project. Anyway, this one was only $16, and that included shipping. So I've already got the other carb off. Let's throw this one on and give it a try. Although maybe not so fast. If I move the carb around, I mean, I hear the float moving, which is fine, but I think I also hear the needle banging around in the bowl. So let's just drop the bowl real quick and see what's going on. Ah. That was the pin. The thing is, the pin's already in there. So, yeah, I guess an extra one got lodged in there during the build, but we do have a pin. Looks like we have a needle. So nothing actually fell out, although having that extra pin in there certainly would not help this carburetor run properly. Well, I think we're off to a good start. Aside from the extra pin, the carburetor did accept fuel and the needle shut the flow off. So we're ready to get this thing started. And one thing to note here, that this carb is actually an improvement over the one that came on this machine and the one that I put on there, because we have an adjustable pilot needle. Currently it is set to half a turn out. If the engine's still running lean, we can back that out a bit more to hopefully correct the issue. The other carbs, they actually do have that needle, but they're set at the factory and either broken off or capped off, so you can't fine tune it, and it also makes cleaning the pilot circuit difficult. Anyway, let's see what this one can do. Well, that's not good. Let me open up that needle a bit. Huh. Well, I would say that was a fail. I adjusted that needle. It made a small difference, but it couldn't correct the issue here. So I'm going to pull the pilot jet out. Just double check the size of it. Maybe put that one in there that I already drilled out and see if that makes it any better. So I double checked the pilot jet I pulled out. It was the same as all the others I already measured. So this one is the one I drilled out 2 sizes over. So that should make a noticeable difference if the pilot circuit's working. So let's see. Yeah, that's all it was. The pilot jet, it was too restrictive, and I see that a lot on this size engine in the 212cc Honda clone range. Even the new carbs, they're lean. The pilot jet was the factory size, and that didn't cut it. So the one that's in there now, it is drilled out 2 sizes higher, and you could probably go even a 3rd size up if you had to. Right now, I think we're about a turn and a half out on that needle. So those settings seem to be pretty good. So I think we can cross carburation off the list. So let's move on and get this tank cleaned up. So let's just take a closer look here at the starting point. The side of the tank closest to me is actually fairly clean, but down the center and kind of the front side of the tank, we do have a bunch of surface rust. And we also have the pre-filter that fell in the tank. So I'm going to try to fish that out before we start. Anyway, to clean the tank, I am going to use Evaporust. It works pretty well. A container like this is about $25 for a jug, and it can only absorb so much rust. Then it starts turning dark, becomes less effective, and it starts to stain the tank. So the more Evaporust you can put in there, the better. In my case, I do have 2 containers. So I'm going to pour both of those in. Before I do that, though, I'm going to use nuts and bolts and some water just to shake it around. I want to knock off as much rust as possible. That'll do 2 things. First, the Evaporust will have an easier job cleaning up the tank, and we're also going to get more life out of this Evaporust as far as how many tanks we can clean. Anyway, let's get that pre-filter out. we'll get the nuts and bolts in and get this thing cleaned up. It's a pretty useful tool for fishing stuff out of tanks, or even just mopping up dirty tanks. Pretty dirty. Anyway, I'm going to do this a few more times, and then we'll be ready for the Evaporust. Where are we leaking? I'm just drying the tank. I'm gonna tip it back, and I'm fairly certain we have a hole right there. So yeah, if that's the case, I would say this tank is not a good candidate, because once we de-rust it with the Evaporust, we're going to have even less material and more holes. You know, you could patch them, but that's not a repair I want to do. You know, I'd rather do it right. So let's just flip it over, see if we get any drips. And yeah, it is dripping from the bottom of the tank. Actually, in a couple spots. We got a leak right there. Maybe one right there, and a couple others. So yeah, unfortunately, this tank is shot. New tank showed up today, and it was already opened when it arrived. So I would say, got mistreated a bit during shipping. And it's pretty common for these tanks to get dinged up. A lot of times the metal on the corners get bent, so you might have to tweak it a bit. Anyway, this one came from eBay, and it was only $39. That includes shipping. So yeah, for a Honda clone, it's really hard to justify trying to bring back an old tank. You know, the tank I was trying to save, I was going to use $30 of Evaporust, and for about $10 more, you can get a brand new tank. And this one actually looks perfect. So there is a little assembly that's required. We need to attach the fuel gauge, which I don't see the hardware for it, so that could be an issue unless it's inside the tank, which it looks like it is. We have a little bag of goodies here. It looks like the rubber insulators for the corners. We also have the screws for the gauge and the fuel valve. So let's get that stuff installed and put this on the generator. Forgot something here. There is a fuel filter that came with this. So it should screw in right there. And on Honda clones, this is usually the only filter. That leads from the tank to the carburetor. A lot of times there's also a pre-filter when you pour the fuel in, which this one also has. I think that worked out pretty well. The only downside about these tanks is that they always come in Honda red, and sometimes it really clashes with the coloring of the generator. You know, in this case, it looks pretty good. Anyway, we've got one issue left, and that is the airbox. The pipe for the tank vent broke off, and luckily the new tank doesn't require that. It has a vented pipe, but we do need to plug this hole because it's behind where the air filter goes, and potentially some dust or dirt could get in there and cause issues with the engine. So to patch that, you could do the easy thing and just use a bolt to plug the hole. You know, a piece of tape would do, maybe some JB Weld. In my case, I'm going to use this automotive Christmas tree fastener. It's a pretty quick install and should effectively plug that hole. So if I bought the right one, you should be able to just push it in, and yeah, it's effectively in there, and it's not going to vibrate out. So I think we're good. And before I get the airbox on, it's a good idea to do the fuel line, because once that box is in the way, it makes it a lot more difficult. It's really weird. The paint on this machine isn't like rusty or damaged, but it's extremely, I don't know if it's sun faded or just a really flat black. Anyway, this is just a little bit of WD-40. Gives it a nice shine. Not permanent, but it does make it look pretty nice. All right, pretty much ready to go. I've got the external test tank plumbed in and 3,000 watts of load on standby. So I'm just gonna get it started. We'll let it warm up. We'll double check the outputs, and then I'm gonna put a half load on of about 1,500 watts. We'll see how it does. And then I'll bring it up to 3,000 watts and double check the outputs. Now, it will be a bit interesting to see if it can do it. I've had issues in the past with engines of this size going over 3,000 watts. And in this case, when I turn these two space heaters on, we should be at about 3,000 watts, plus we'll have this light turned on, which is another 70 watts. So we'll be getting pretty close to the 3,200. So let's get it started and see how it does. Uh-oh. So we're starting at 4.3% THD, and the sine wave, I'll take a screenshot and put it up on the screen. So the engine's holding fine at 1,500 watts, and surprisingly, THD is still at 4%. That's not too bad. Now we're close to the rated load. We're still at 4.6 THD. That is really surprising. I am completely blown away by what I just saw on this. The THD started at about 4.3%, no load, and under a full load, it only went up a tiny bit to about 4.7%, so virtually unchanged. And I don't see that often from a non-inverter generator. I've actually only seen two others that perform as well as this one. Usually under a full load, the THD goes up to 20 to 30%. So yeah, this one's kind of in a class of its own, which is surprising because brand new, this was a $300 generator. And the only others that have tested the same as this were much more expensive multi-cylinder generators in the $2,000+ range. So yeah, this one, it is performing better than most I have tested. Anyway, this one didn't need a whole lot. you know, was mostly due to neglect. It needed a new tank, a new carb, and some wiring issues sorted out. And now this is running better than most. So I hope this video helps someone. Thanks for watching.